I've already introduced blocks when talking about the iteration constructs available in Ruby. As a reminder, a block is a piece of code between do-and keywords or curly braces. By convention, the do-and keywords are usually used for multi-line blocks, and the curly braces are used for single-line blocks. The only way to use blocks is to pass them as an argument to a method. Some methods can take a block as a special kind of argument which comes after the regular arguments. Methods are able to execute the code in the block once or multiple times. A method can also pass arguments into the block when it executes it. Block arguments are specified between vertical bars at the start of the block. So far, I've been using blocks, but I haven't shown you how to write a method which can take a block argument. Let's rectify this. In the simplest case, you can just use the yield keyword to execute the block at some point in your method. For example, I could write a method which takes a block of code and executes it only in debug mode. Let's go over this method line by line. The first line aborts the execution if the debug mode isn't on. The second line uses the blockGiven method to check if a block has been passed to the method. If not, the method returns nil. The third line produces some output, and finally, the last line is the yield keyword, which executes the block. I can call the debug-only method without arguments, and it will do nothing. If I pass in a block, it will be executed as long as the debug mode is on, of course. If the block requires arguments, you simply pass them to yield. For example, I can pass some debug attributes into the block instead of exposing them in the interface of the class. Using yield is similar to a method call. The value of yield is the result of executing the last expression in the block. Block arguments are similar to method arguments. They can have default values. You can use keyword arguments as well as specify array arguments using the split operator. Here I've got a block which has all possible types of parameters. I invoke the block with a set of arguments within the produce method. When I run this program, you can see that these arguments are correctly assigned to variables within the block. I don't expect that you'd use such complex block parameters in your everyday work, but having parity with methods on this front is useful, as it's possible to use blocks when defining methods dynamically. An important property of blocks is that they are closures. Well, almost. They carry their context with them. This includes local variables, class variables, constants, and the value of self. A block executes in this context. Normally, this is very convenient, as you don't need to pass in everything as arguments. For example, here I'm printing the debug attributes hash in the block. This hash is stored in the debug attr's instance variable. I don't have to pass it in as a block argument, and it doesn't need to be accessible outside of the class. As the block is defined inside the class, it's able to access the instance variable. The only non-closure-like aspect of blocks is that if a block contains a return statement, it's executed in the scope the block was defined in. This can be problematic, because that scope may no longer even exist by the time the block is executed. In this file, I define my spaceship class, and it has the debug-only method from the previous examples, and then I made the misguided attempt to limit block execution to a particular instance of spaceship by returning if the name isn't right. When I run this code, I get an error. This is because the return is executed in the outermost scope, not within a method. The reason for it is that the block was defined in the outermost scope. Another issue to look out for is memory use. Blocks carry their context with them, and it can prevent large objects from being garbage collected, as they are still referred to by the block. Blocks are an extremely useful feature. In addition to allowing you to factor out common code into methods, they also enable iterator methods, which are a powerful alternative to regular loops. They also provide other possibilities for cutting down on boilerplate and making code clearer. As an example, a common Ruby idiom is execute around. If you want to be able to time the execution of some pieces of code, for example, you could do it like this. This method records the start time, then executes the block, and then calculates the time it took to execute the block. I can then define a couple of operations, and then I can run them in a block passed to the withTiming method. The same approach works for logging before and after a group of statements. Another variation of this idiom is transactional code. For example, you might want to ensure that the file is closed after being processed. Or you might want to model wrapping a bunch of database queries in a transaction. Both of these things are easy to implement with blocks. This example shows how to implement transaction support. The transaction method executes a block, but the execution of the block is wrapped in a begin rescue end clause. If any of the statements in the block raise an exception, the transaction is rolled back. If everything goes well, the transaction is committed. I can then call this method and pass it a block which does multiple queries of the database, and they will be wrapped in a transaction. However, blocks also have limitations. You can only pass one block to a method. You can't pass it on from the method that's called with a block to another method. And what if you want to pass the same block of code to several methods? You have to duplicate it, and it's not going to be very dry. If only blocks were objects, like most other things in Ruby, it would solve these issues. It turns out that you can give a block a name in the method parameter list. In the example here, the block is given the name block. Note the ampersand before the name. It tells Ruby that this is a name for a block, not a regular parameter. Once you have a named variable, you can check what its type is. Let's run this code to find out what it is. The output tells me that the block variable is an instance of class Proc. I'm going to refer to these instances as procs from now on. A block isn't actually a proc, but it can be converted to one, which is what I've done by prefixing its name with an ampersand in the method parameter list. Naming a block parameter isn't the only way to get a proc. You can also create proc objects directly by passing a block to proc.new. Alternatively, you can use the kernel method proc included in the object class to create proc instances. The proc method is simply an alias for proc.new. There are several ways to execute the code stored in a proc. You can use call or yield methods. You can also abbreviate it to a dot followed by a parameter list in parentheses. Finally, you can use the square brackets. Now that you have the ability to convert blocks into named objects, it's easy to pass them between methods and refer to them via variables. It's now easy to implement things like callbacks or lazy initialization. All you need to do is store the proc in an instance variable and call it at a later point, when you need to invoke a callback or run some initialization code.